Hey guys, welcome back to the Dumont RA-102 console television restoration project, better known as the Clifton. Hey, before we go messing around with troubleshooting the AM radio, how about we try powering up the TV, huh? I mean, after all, that's kind of what this project is all about. Now, I do still have the weak repaired 807 on the power supply that drives the high voltage coil. I could swap it out with the 807s and the deflection circuit, but I'm kind of would rather have some good tubes in the deflection circuit than the high voltage, because I don't want to have high voltage and no deflection, or I could damage the CRT. I don't know. A forum member from the Antigua Radio Forum is helping me out and sending a couple on my way, but they won't be here till next week most likely, and then the convention's coming up, so I'm going to be out of town for a while. So let's do what we can. I mean, what do we got to lose? Either it's going to work or it's not, right? Replaced all the caps. Replaced some bad tubes. So let's pop the 5 U4s in for the 400 volt supply. Got my high voltage probe out. Got a fluorescent bulb so we can see if that high voltage coil is doing its thing. Fuse protection, we got a circuit breaker in our Variac, so let's just go for it. Alright, so power going into the set, turning it on. I believe I left it in FM radio mode. Yep. Alright, so let's go to TV mode. That's radio mode, FM radio mode, TV mode. Let's to the TV band. Alright, so do we have any high voltage? Let's put our probe over here. We do not. We do not. Is anything doing anything over here? The 807 is lit up. The high voltage rectifier is not. Now, it could just be a bad high voltage rectifier. I'm not seeing any activity in that high voltage coil, though. U4s are all lit up. Alright, something's not working right. So it could be the horizontal oscillator's not working right, because that's supposed to disable the high voltage if the horizontal oscillator wasn't working. So it's a little weird in that horizontal oscillator's on the main chassis, but the high voltage supply is over here. And they need to work together for this all to do something. Alright, let's see, I replaced the 2 weak 6S77s over there. I don't know that I ever checked this one, though. I think I did. Trying to think if the 1B3 was bad. Relay just kicked off there. I think this, I don't know, in other words, would a 1B3 prevent the feedback, to prevent the oscillator, to prevent the coil from doing anything? I don't know, but I certainly have some new old stock ones handy, so let's power this down. Make sure there's no voltage here. Let's just pop that. I've encountered so many bad 1B3s and sets that I just immediately assume they're all bad these days. Hard to tell just by another thing I want to let's pop this in. Another thing I want to do is verify that we actually have the 400 volt supply working. Need to tip this thing on its side to get under there to check that. So let's make sure that it's completely plugged in. Alrighty, here we go again. clicked. Do we have anything going on now? No. Well, I am going to try swapping out that 807. It occurred to me, if I pop the high voltage lead off the CRT, I won't be, there's no chance of me damaging it by not having a moving dot. So we'll just put that over there. And let's pop one of these guys out. Do a little swapping. It's a lovely looking Raytheon. And I am going to swap out the 6S and 7. Alright, here we go again. Nothing. AM, FM, TV. Heard the relay click. Nothing on the plate of the 807 either. So let's, I'm just going to leave my high voltage probe in the meter. We'll just have to multiply the reading we get by 100. So, relay clicked over. Ooh. We don't. Nothing. Let's see here. It's these two rectifiers. .467. And then hook the relay up right. .464 and nothing. Maybe I got the relay contacts backwards. And I'm I'm not sure what's going on there. Shut everything down. So it looked like I had 423 on one relay contact and nothing on the other. Oh, yeah. So this relay, it's going to normally open, normally closed, and then the common contact. So you get common contact, these two, and you can go this way or this way. I have my two wires connected to these two, and nothing going to this guy. There's supposed to be a wire going to this guy and to this guy. So when it's powered up, these two connect. Alright, let me do a little switcheroo on that wiring and resume. Alright, let's give this another try, shall we? Alright, so AM mode. FM mode. TV mode. Now we got plate voltage. But no high voltage. Pretty steady at 384 volts. Well, there actually is a little something on the plate of the high voltage rectifier. So on the output. There are a couple adjustments here. I was thinking maybe the pots are dirty, and if I just tweak it a little bit. .002 volts or kilovolts. Okay, we got more work to do. So one thing I want to know is the oscillator for this high voltage generator even running. There's a handy application for the little portable scope here. I don't want to risk frying my good tech scope. I got times 100 probe on it, so it should be protected from any higher voltages. Let's fire this back up. Got a few pins we can check. Seems to me the grid on the 807 is a good place to go. I gotta admit I'm a little rusty on how to count pins on an 807. If I trace out the circuit, so it's where the 27K 1/2 watt resistor connects, so that'd be this guy. That didn't look right. It's not showing me anything. Now, I should also mention, I still haven't replaced the few paper caps that are on this vertical riser here. But I don't think that's the horizontal oscillator, but that could be affecting things. But I also just swapped the 807s back, because the control signal for this comes from the horizontal output circuit, so maybe by putting a weak 807 in that, it screwed up this control signal coming back this way. So we'll give this one last try, then I'll switch back to the main chassis, and I'll just bite the bullet and pull the CRT and get in there and replace those last few paper caps. I mean, it's always the caps, right? And also want to see if you guys can get a get you in closer to see if you can hear the sound when I turn this set on, which sounds a little disconcerting, but I think it's just because the set draws so darn much power. Here we go. Relay clicked in. Okay, so how about this time? Nope, still got our 0.002 kilovolts. Yeah, that made no difference. Alright, so be it. Well, nobody said it would be easy. Well, surprise, surprise, that's exactly what's on this vertical support. It's a horizontal oscillator. So horizontal oscillator, reactance tube, phase discriminator, and a phase discriminator transformer. So, yeah, very likely the horizontal oscillator is not running because I haven't recapped that yet. So, we need to unmount the CRT, do that by loosening this up. Foam has hardened a bit. Get that loosened up. I'll have to take off the iron trap magnet. Take off the base, slide this out, undo the support screws for this vertical column from below, and hopefully that will allow me to manipulate it enough that I can work on it. Depends how long the wires are coming up to it. Yeah, not much fun. But hey, at least with that out of the way, I can also gain some access to the AM tuning cap down there. So we may want to tinker with that as well while the CRT is out of the circuit. After all, none of this stuff's going to have power, so we can work on it. We can power this up with the AM radio with the picture tube out, in other words. Alright, picture tube has been removed. That was pretty easy to do. Just loosen this up and carefully slit it out after disconnecting it. I think I just may be able to work in here without removing anything. There's only 4 paper caps. 1, 2, 3, 4. A mess of power resistors and some mica caps. I will do my best to get in there. Same type of seal tight, crummy capacitors, so I am sure they are all very bad. Meanwhile, I am testing the pitch tube. It's been many years since I have, and yeah, it is on the weak side, unfortunately. I'm running it on 7 volts right now, and it's been slowly creeping up. It'll produce an image, but no, it's not great. So be it. I seriously doubt I would ever see another 12-hour P4. It's the only one I've ever seen in my life. And nobody's rebuilding these right now, so if I had to, I would modify the high voltage connector and use something else like a 12kp4 or 12lp4. Far more common. But we'll go with this for now. Alright, back to the recapping. Alright, with a lot of J-hooks and patience, some swearing now and then, I got the 4 new caps in there. And as for the old ones, yeah, maybe there's our problem. That is one miserable looking cap. The others aren't a whole lot better. Alright, I'm going to pop CRT back in and give this another try. Actually, no, let's give it a try without putting the CRT back in. We can measure the high voltage without it. Alright, round 2. I think I'll leave the CRT out even if we do get high voltage back. If I want to see an image, I can always pop in a little test CRT. It's just easier to work on with it out of there. Okay, got that hooked up. High voltage lead is off in the distance safely. Alright, there we go. That's on. I left this in AM mode. Turn some lights down a bit. Warm up for a little while. FM radio, TV, click, high voltage. No. In fact, if anything, we have even less than that, which is flat out 0. Well, I still have some tubes to check on that vertical column. It seems unlikely that it's usually not as simple as that. Okay, we got our voltage there, voltage there, and no voltage here. Well, now that's nice to see. I'm looking at pin 3 of the horizontal oscillator, which they show right down there, and we've got 15.79 kilohertz, which is pretty darn close to what it should be. Now they show an amplitude of 215 volts. I got volts peak to peak 18. I got a times 100 probe and a times 10, so it's 180. So yeah, we're in the ballpark. 215 versus 180. Okay. Now the actual control signal that goes to the high voltage supply is downstream of this. It's after the oscillator. We've got some other stuff. So I've got my probe way over here. But it goes from that and goes to this horizontal saw generator, a 6SN7 V18. And that goes to the 807s, goes to the horizontal deflection transformer, and our control signal comes way over here. It's actually on the red and black lead of the horizontal deflection yoke. So just because we got something good here, we got all this stuff in between here has to be good. So let's jump right to that, the red and the black lead, because they also show that on the waveform as well. Red and black lead on the deflection coil should be 25 volt peak to peak sawtooth. We just got to find the red and black lead on the yoke. It's going to be one of these wires over in here. Not so easy to get at that, unfortunately. The wire is insulated all the way down through to the bottom of the chassis, so I had to put this thing on its side while keeping stuff connected. Comes out right here to this 27 ohm resistor. Alright, let's give this another try. Relay. So we do have a triangle waveform. It's 15.85 kilohertz. Volt peak to peak. It's only 632 millivolts times 10, 6.3. That's a lot lower than it's supposed to be. Could be because it's off frequency. It's supposed to be 25 volts peak to peak. So we are way low on that. So which one of these myriad controls do we adjust the horizontal oscillator frequency with? Or the drive control? By the way, I did take out a couple of the shafts while I was working on this, as some of you had suggested, and I still haven't put them back in. There were labels on the front showing what the controls did. They fell off, but I do have them, so I'm going to go grab that and see if I can figure out which of these pots does what. Actually, let's look at the schematic first. Oh, I'm also going to review the setup procedure on this. I'm used to bring in just, oh yeah, I do have a dual coil, horizontal phasing, horizontal hold. This transformer here, but I don't know where exactly those are accessible. These are all potentiometers, so it's none of those. Oh, there is a pot down here. See note 3. There's a horizontal peaking control, horizontal size control, horizontal damping control, horizontal linearity control, horizontal position control. I think horizontal hold's what we want. Red, green. So I need to figure out where this thing. Oh, that's the transformer on that vertical support part. So let's see if that transformer has some, I don't know, screw adjustments or knobs sticking out of it. Okay, yeah, there is a threaded shaft coming out of the coil, and I adjusted it with this tool, and I got the frequency. Actually, it's down to 15.58 now, so I can adjust the frequency very readily with that. This must be a type of set that, once it's factory adjusted, they didn't think the user would need to adjust the horizontal hold. I don't know. Doesn't seem to be a horizontal hold control readily accessible from the front. But that's irrelevant because that did nothing for the volts peak to peak. So, we've got to do some more investigating here now. I put the 2 strong 807s back, driving that push-pull transformer, which is what drives this coil. But there's a whole lot of other parts in there, and I have not checked everything. I did check this 27 ohm resistor, but yeah, there's a bunch of other resistors I haven't checked. So I got more work cut out for me now, I think. I got to go through this a bit more methodically. I don't think I'm just going to say huzzah and it's going to work. So this is essentially the control signal that's going back to this, and it basically uses this frequency to drive that oscillator that drives that coil. So in the absence of this signal, or this signal not being the right amplitude or frequency, this does not work. So I'm pretty sure that's where our problem is. I think I'm onto something. This control up here is a horizontal size, and by manipulating that, I was able to increase the waveforms. It had been down around here. If I max it out, I can get it up to 34 volts peak to peak. We're looking for 50. Now there's also a potentiometer up here that you access from the top of it. It's kind of between the 2 807 tubes, and that is horizontal peaking. And if I adjust that, check this out. It's not the easiest thing to get at. Alright, here we go. So one way it goes down, the other way it goes up. Hear that? I hear singing. I'm up to 40 volts peak to peak. Now the waveform isn't quite what it's supposed to look like, but we've got much larger amplitude. Actually, it's too much now. It's 62.5. But that singing sure sounds like a high voltage circuit to me. So let me move some stuff aside, get my high voltage probe back out, and see if that was enough amplitude now to activate the high voltage circuit. I'm thinking yes, because that sound is very familiar to me. Oh yes, we have high voltage now. There. Get you guys in on the action. Remember, we have a weak 807 here, so that may very well affect things. Alright, so... and 7.3 kilovolts. Woohoo! Boy, is that loud. Curious. If I adjust these pots down here, should be able to change that voltage. Yep. Sure can. Not going to worry too much about the exact voltage because we know we have a weak 807. I've been monkeying around with these controls. That waveform is not quite what it's supposed to look like. It's too large an amplitude right now, so I'm going to turn that back down a bit and flip this back down, and let's try popping a CRT in there. Not the safest setup, I admit, but this connector is not going to fit onto that CRT, so I'm using an alligator clip, but I want to keep this out of the way of everything. Luckily, they put a little retention clip here for this insulated high voltage wire, so at least for a brief test, I think we're okay. Let's give it a try, shall we? Again, I don't exactly know what controls are what. We need to identify brightness for sure. Should be one of the main controls, I would think. That's mode, that's power tone, that's volume, so maybe one of these two. High voltage is kicked in. Don't see anything on the CRT. Ooh, 9.3 kilovolts. All right. It's just that easy. Woohoo. Boy, that ringing is loud. My upper frequency hearing isn't so hot these days, so I can hear it, but some of you can really hear it. How cool is that? Now I can do something crazy like inject a signal. Troubleshooting would be so much easier from... Ooh, we lost vertical. Oh no, it's just about to take a picture of it. Crap. Well, usually the vertical circuits are a bit easier to troubleshoot. Well, I get a picture of a line anyways. This is why I use test CRTs. I'm not particularly worried about burning a line into this. So I'd be going into from TV mode to, and yeah, now I can finally verify that when you go into the final mode, it kills the dial lights, but the TV mode keeps working. It's TV mode with dial light, FM radio mode, high voltage cuts out. All the tubes keep running, by the way. There's a type of set, when you do these combo sets, it's tough. So they just leave all the tube filaments running all the time. So you listen to AM radio for hours and hours and hours while you're slowly wearing out your picture tube and all the other tubes in the set. So they all run all the time in every mode. Oh, and we have vertical back. Get a picture, get a picture.